Welcome back and thanks for tuning in. It's been a couple of busy weeks. I've had a lot of projects, and one of them involved repairing a bunch of metal downspouts. I'm not sure if you're familiar with the material, but it's like a 3x3 very flimsy metal, and the part that gets damaged is not so much the part that goes down by the side of the house, but the section that directs it away from the house, which is near the bottom, and it tends to get covered in snow, trodden on, and of course damaged by snow removal people and all that sort of nonsense. So I need to fix a number of these, and it comes in 10-foot lengths, and there's a number of ways you can cut this. A hacksaw is the easiest and cheapest way, of course, but if you've ever done it, even if you have a very fine-toothed blade, when you are cutting down through it, it just tends to bind a lot. And, well, I'm a lazy guy. I don't really want to hack away at these for any length of time. So another way of doing it, of course, is to use an angle grinder with an attachment, which is allows you to put an abrasive blade in there, which will cut through the metal. Now, the platform I have, the battery operated system I have, does not have an option for angle grinders. I could, of course, went out and bought a new system, but that would be expensive, and I don't really do that many of these, and it wasn't really worth it. So what I thought I would do is make an arbor, one that I can attach to my drill and put the disc on that, tighten everything down, of course. It will be a bit further away from the center of gravity. If you know what an angle grinder looks like, the blade is actually quite central to where you hang on to. But with a drill, it is about another 3 or 4 inches away from that. So there's going to be a bit of torque on this, but considering it's just going to be very thin, flimsy metal I'll be cutting, and that's all I'm going to use it for, I don't think it'll be much of a problem. So what I've done here so far is this is the part it will be turned down and will sit inside the chuck. Now, I started off with high-speed steel to turn this down. It gives a nice finish, but you can't really hog off a lot of material, even though this is just aluminum. So I switched over to carbide, which allowed me to turn this down a lot faster, and of course, spend an hour and a half at the lathe just setting up this one part. So now that we got it down, I am going to switch this all around and start working on the part that matters, and that's a simple matter of cutting this to the length I need, and then facing that off, drilling it, and then of course putting threads on that because I want to put a bolt on this. And one of the things I was not really agonizing over but debating was I was concerned that there wouldn't be enough friction, even with a stainless bolt holding this in place, that it would hold it solid enough. So I'm going to leave a little bit of extra on here just in case there is that issue. And what I'm going to do then is find a source for something I can cut some rubber washers out of, and then be able to tighten it down and have that extra bit of friction that way. So I'm just going to using a cutoff here just to trim this down to size. As you see, it's quite beefy, and the reason I went that way is because this is aluminum. I didn't want the hole, even though it's only 1/4 inch, to weaken the structure. So I want the whole bolt to be inside this big fat part. And what I'm going to do is, I didn't want it to come down into the part that fits into the chuck. So there won't be any risk of a thin wall right at that juncture. So it's probably a concern that doesn't really exist. But I wanted to make it extra safe. And what I want to do, of course, is if this turns out to be something really functional, and I like using it, and I might want to use it for something else, I can always trim this down. I can always make this much more slimlined. But anyway, I want to test it out. I want to leave a lot of material on it, and I want to get it to be as, like I said, as functional as possible, and as simple to use as possible as well. So this part doesn't need to be any particular size at all. I'm just trimming it down to be nice and shiny, and of course I faced it off. And then all I need to do now is set up. Well, this is where this is the drill for tapping the hole, and that's the 1/4 inch bolt that's going to be in there. And leaving a little extra room because my taps are not bottom out taps, so through taps, so they have kind of a pointy lead, and I want to make sure that it doesn't bind at all. So there you go, a little bit extra on there. And of course, this is not taking into account the fact that there's also going to be washers and other stuff there as well. So I forgot to film using the center. It's very important to do that on something like this, because you want to make sure that, as you see, this spins true. And watch as the drill bit goes in. You want to make sure it doesn't deflect or wander at all, and using the center, make sure it doesn't do that. And there you go, it doesn't do any kind of deflection whatsoever. And then of course, once that's all set up, just put a little bit of WD-40 to help the cut, and then just drill that out. And then I'm going to cut out tap the hole. Now, one of the things that I didn't show as well is I use WD-40 for most of the cuts on this, especially the tapping. And what that does is it obviously coats the inside of the threaded holes with oil. And if you just leave it without, or try to blow it out with air, what happens is the bolt just binds because there's all those little shards in there, little bits and pieces of aluminum. So what I do to get around that is the WD-40 has that nice thin red nozzle. I stick it down to the bottom of the hole, and I just spray all those out. And it's test the bolt and put it in a little bit, see if it's not binding, whatever, and then of course repeat until it's nice and clear. And there you go. One of the things also I forgot to do at this point is mark where the bottom of the hole is going to be. So I stopped and took the tap out, and again marked it with a piece of tape, and then finished off the holes. So there you go. And that is as simple as that is. Now there's one other thing that needs to be done. This is basically finished. There's nothing that needs to be done on this. But the thing is, the hole size for the disc, the cutoff disc, is designed for fitting on, the standard size for angle grinders. And that's not 1/4 inch. I think it's 5/8. I'm not exactly sure about that, but definitely way bigger than 1/4 inch. So the problem is you can't just take a washer and put that on. It's going to wander all over the place, and even if you manage to tighten it down enough, it's not going to be it's not going to run true. It's going to have a bit of difference in circumference as it goes around, and what's going to happen is it's just going to bounce and chatter all over the place, and you can't have that. That's just going to make it almost impossible to cut a proper hole or proper line. So this is the problem. See, even if I tighten it down, this is obviously exaggerating, but the hole's just way too big. So what I need to do is I need to make a washer. Now I had a bunch of, this is 1/4 inch aluminum. It was this flat bar. What I'm doing is I'm just made a temporary mandrel here, tighten it down, and I am just turning it down and around. It's not difficult to do. It doesn't take very long. And once it's down and around, the lead face that you see here facing us is the one I'm going to gradually turn down until I have a nice snug fit that's going to fit in that hole on the disc. So you can see right now, just near the bolt is the face. That is the washer. Now that section can't be thicker than the disc, and I have to turn it down so it's nice and snug. As you see, it's not quite there yet, and this is a slow process at this point. I have marked where the settings on the lathe all are, so I just move it back over to those positions, and you'll see it'll hesitate for just a second, and then I'll move it in just to where it needs to be. This is not touching anything at this point, and then I'll move it away from you and down towards where that locking system is going to be. You can see it's just clearing off some dust here, and then making sure it's close, and then of course this part has also been registered, and I will just take off another 1/100 of an inch each time, and until I have it fitting properly. And it actually worked out quite well. There's probably a bit of forgiveness here, but I wanted to make sure this is snug. Because I hadn't made one of these before, I wanted to make sure that it worked properly. I didn't want it to not function simply because I got a little lazy near the end of this and didn't make it as tight as possible. So here we are, it's done. Did some sanding off screen, or off camera I guess I should say, and that's it. That now Fits very snugly into this hole. And I'm going to tighten it all down here, and we're going to have a look at it. So there you go. It doesn't wobble. I can see just a tiny bit of wobble. I don't think these things are that precise when they make them. So it does have to fit multiple discs. So once this disc is worn down, I'm going to have to put another one in. And hopefully I wouldn't have to adjust this at all. So this washer you see here on the outside, that's just temporary because it's going to get replaced, I suspect, by rubber. And it's going to be between the abrasive disc and the aluminum. But for the moment, I just want to try this out. And you can see it's oversized. It's not, like I said, it's not meant to be in the final product. But I want to lock it down and see how well it spins, and then of course test it out on a piece of, well, the very thin metal that the downspouts are made out of. It's nice and solid. And now, just like I said, just a simple matter of popping it in here, making sure it spins true. And then the final clip here is going to be it working. And you can see it spins nice and true. And that's really important because I don't want this to wander all over the what I'm cutting. And because like I said before, there's a fair amount of distance between that blade and the handle I hang on to, and that's going to put a bit of torque on this, and I want to make sure I keep it nice and straight. So here we go. It's maiden voyage, and it cuts very, very well. I'm very happy with this. It worked out really well. As you can see, it just slices through very easily. Went the wrong way, turn it the other way, one more cut, and then we're good. Thank you very much for watching. Leave comments. Let me know what you think about all this sort of stuff and ideas for other projects. And I'll see you in the next video, and bye for now.